Hi everyone, our group will be proposing acetylene production from associated gas. So one question, why do we propose to produce acetylene from associated gas in the first place? Firstly, being one of the top 10 countries for gas flaring in the world, Malaysia contributes to about 4,000 million meter cubes of gas flare per year. Since we'll be now using this associated gas to produce acetylene, the amount of carbon dioxide flared to the environment will be significantly decreased. Secondly, we know that Malaysia is rich in crude oil resources. If 5% of this crude oil produced is contributing to associated gas, think of how much associated gas that we will produce. Therefore, we can effectively use these waste resources and turn it into profit while reducing air pollution. Now this is the main plus points of our business. Our product, acetylene, is one of the oxy-combustion gas with the highest flame temperature. Therefore, it is most commonly used in the welding industry. In addition to that, chemicals can be derived from acetylene, for example VCM, benzene, and also acetic acid. Moving on, the increase in global acetylene market has shown a compound annual growth rate of 3% towards year 2020, meaning that there is a continuous market for this chemical. Finally, we are located in Kerteh, Terengganu, and we have an advantage of easy uptake of feedstock, which is associated gas from an offshore platform located also in Kerteh.
I will now discuss about the economics, feasibility, and profitability of this project. Okay, first off, the capital and product cost. In order for this project to get started, we need around 2.94 billion ringgit and a product cost of 344 million ringgit per year in order to keep it running. Speaking of the payback time, we have calculated 5 different scenarios from best to worst, and at most the payback time is in 3 years and 3 months, meaning in that short amount of time you will get your profit. And to further analyze the profitability of this project, the internal rate of return and return on investment are both calculated as well. And the lowest IRR is at 29% and the lowest ROI is at 13%.
Now for the sustainability concern.
If the associated gas is being flared, then the amount of carbon dioxide emission is 3,308 kmol per hour. This amount is reduced in our process. The amount of carbon dioxide being removed from the TSA column is 2,313 kmol per hour. The carbon dioxide emission is reduced by 30% in this process compared to flaring. Next, we will be looking at the effect of carbon dioxide emission.
This higher amount of carbon dioxide emission will result in ocean acidification, where the pH value decreases due to increased carbon dioxide absorption by the sea. This will impact ocean life, including their soft and hard materials and also human-built structures in the ocean. Next, high CO2 release is the primary cause of global warming, since carbon dioxide is a greenhouse gas. This causes the ice glaciers to melt, which will then lead to sea level rise. This is also due to thermal expansion. The global average sea level has been rising at about 3 millimeters per year for the past 20 years. One of the examples is Bangladesh, where it is projected to lose 17.5% of its land if sea level rises about 1 meter, displacing millions of people. Several islands in the South Pacific and Indian Oceans may disappear entirely. Therefore, it is important to reduce carbon dioxide emission, and this is done on our process by sending the carbon dioxide gas for secondary recovery method.
Now I'm going to talk about the process. This is the block diagram for entire process. For pre-treatment part, methane is extracted from associated gas and oxygen is extracted from air. In reactor part, oxygen and methane is undergo partial oxidation to form acetylene and other side product. While in post-treatment part, methane and hydrogen is extracted out. In the whole process, 55 tons per hour of associated gas is undergo this process, and it will produce 60 tons per hour of acetylene, and acetylene is then stored in the gas cylinder. Besides, it also generates 3.6 tons per hour of hydrogen, then hydrogen gas is later generated into electricity.
In conclusion, the process of this project is viable. It is also economically feasible because we have the return on investment is 13% minimum, and it is ultimately sustainable because in total we are reducing 30% carbon dioxide emission.